All right. Well, of course, last time we finished off talking about the linear search. And of course, we all saw that that implementation right there is terrible. It's broken, right? But what's wrong with it? Who remembers what the issue was? What do you say?
It would only ever check the first letter in the word, because once it hits return, it stops running altogether.
Exactly. That's exactly what the issue is. Because it says, okay, well, counts is less than the length of the string. Great. If the string at index counts as the character, we've got an if statement with an if and an else. So one of those two are going to run. If it is the character that we're looking for, we return true and we get lucky. If the first thing we're looking at is not what we're looking for, we jump to the else statement and we say return false. But the issue is, return immediately stops the execution of that function. So it says return false, done. The function returns false. But of course, we've only looked at the first character. And this comes down to, what is the best case scenario of a linear search? Let's ignore that implementation right there. You know, I've got a string, right? Index 0 all the way to index n minus 1. So what's the best case scenario in terms of the amount of computing required, the amount of steps the computer has to run? Think about it for a second. And when I say best case scenario, I mean like, what must be the case? Like, let's say I'm looking for the letter A in my string. What's the best case? A is the first letter. How many times will that loop run if A is the first letter? Once. Exactly. That's the best case scenario. We might get lucky. Because as soon as we find what we're looking for, we can conclude that what we're looking for is in there. But what's the worst case scenario? I'm looking for the letter A. Where's A? It's the last letter. Or what could be just a little bit worse than that? It's not even there. Similar enough, yeah. So if it's not there, if I have a string of length 100, how many characters would I have to look at to conclude that that letter's not there? 100. What if it was a string of length 1,000? What if it's 1,000,000? Exactly. Now, one thing I want you to note here is the amount of work you have to do scales perfectly with the length of that string. If I double the length of the string, how much more work do I have to do? Exactly. So there's our linear search. Now, I'm just going to throw a bunch of string trivia at you. None of this, there's going to be no part of the midterm that says string trivia or anything, right? I'm just showing you a bunch of things. I'm going to go through this reasonably quickly. I'm not expecting you to look at this and go, oh, okay, I'm going to definitely remember that for the future. No. All I want you to know is that, I'm providing you a reference here, give you a context of what you can do, and then later when you need to use something with strings, you might think, I think I saw him talk about that, so maybe I'll go look into that, right? So the purpose of this is not for you to go oh my gosh, I gotta learn all this stuff right now. No, it's that I'm just giving you this reference. So first things first, strings can be in single quotes or double quotes. It doesn't matter as long as you're consistent. However, I'm going to recommend double quotes for a couple of reasons. One is it becomes you can use single quotes inside the double quotes pretty easily, but really the big reason I'm going to encourage you to use double quotes is it's more consistent with other programming languages. Many other programming languages use double quotes for their strings, and they'll use single quotes for an individual character. So just to make your code more universally similar to other programming languages, I suggest the double quotes, but it doesn't really matter in the end. You can concatenate strings, we saw that. In this case, I've got fun times, but I'm also adding a space in there. So fun plus space plus times gives me fun space time. We can multiply strings, which is pretty neat. I could just make the string repeat itself some number of times. Pretty cool. convert an integer to a string and a string to an integer, right? We saw that. We've been doing that basically in the lab, right? If I have a string, well, there I'm converting an integer to a string, but we can do the opposite, right? We've been doing that in the labs. Whenever we input stuff from Caddis, what type does Caddis always read input in? String if you're using the input function, yeah. So we might need to convert things around. Yeah, we could do that pretty easily. So here I'm saying, well, what's the type of the literal one? And remember, when I say literal, that means like I've just like wrote the value right then and there. I wrote the value 1. I could alternatively say like a equals 1 and then say type of a. A is the variable. So here I'm just hard coding the value. It's the literal. So what's the type of 1? Well, it's an integer. Well, what happens if I take the 1, convert it to a string, and then ask the type? Well, it's a string. And you've probably seen this before, because how many times have you tried to do something like this? Where you'll take your string, a equals 1, print hello plus a. And then you hit run, and it says, well, no, I can't concatenate strings and integers. Raise your hand if you've seen this before. Of course you have. But what's the easy trick? Well, just be like, no, just be a string. All right, cool, it works. What's interesting here is a string can be empty, which might seem kind of like a weird concept, but I mean, it's not too outlandish, so it shouldn't startle you, but it might feel a little weird. Because you might think like, well, maybe think isn't the right word. You might feel as if like a equals print a, print the length of a. And yes, remember, we can ask the length of a. So now like the length, like a is like nothing, but it's not nothing, it's a space. And a space is something. If we wanted to store a space in the computer, we need to allocate information in there somewhere. You know, like it takes up space. The space does. And it's got length 1. But if I do this, and like look, I can even highlight, and it's letting me select the space. See? Ooh. If I go here though and do this, well, it's a string, and let me prove that. Print type of a. Like it's a string, but there's nothing here, and its length is 0. So a string could have length 0. This is particularly handy if you're doing something you might call string building, where if I have a loop, just as an FYI, s equals an empty string, you might find this neat. For I in range 100, s plus equals the str of I. Print I. Let's not do 100. Let's do 10. Oh, plus space. There. Let's do that. Not I, s. So, if I do this, the plus equals, remember, it's shorthand for like s equals s plus. But of course, we've used that in the context of like numbers before, where I said like counter plus equals 1, and that would just increment counter by 1. Where here I'm saying plus equals something else. But it's strings. And plus equals will work with strings in Python. It just concatenates. So this is saying, take the string s that starts as nothing, append to it the string version of whatever I is, followed by a comma and a space. So this is string building. If s doesn't exist, though, I can't like append to it. So s needs to exist, and I don't really want to start it with a space, because then I've got this leading space, which I don't want that. So I can start with this empty string, and there we go. Cool. String building it's handy. You might find it particularly helpful on assignment 3. So we have these things called escape characters, because if I'm typing something away and I press enter, let's go back up here. So if I'm typing away, if you're in Microsoft Word or some text editor or whatever, and you press enter, what happens? Go to the next line, right? But the trouble is, what if I want to print out like a new line? What if I want to print out, like, what if I really want the string, not hello space world, I want hello new line world? The issue here is, well, I can't just go here and press enter because that brings me to a new line. So we're in a bit of a conundrum here, aren't we? So we have these things called like escape characters, where I can say /n. This single slash here tells the computer like that the string, the next letter, like that slash, I don't care what it is. Like don't print out a slash. When it sees slash, it's going to go, okay, slash followed by. So Python cares about the slash and then whatever comes after the slash. That /n means new line. So now, let me go back and change it to the space. Okay, hello world, this should not startle anybody. Now if I do this. Okay, actually, yes, and let's count. How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Makes sense, right? There's 11 there, the length's 11, great. If I go here and do /n, how many characters are here in this string? When I say, how many symbols are in this string? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But this kind of counts as 1. Sorry, it doesn't kind of. It counts as 1 because the /n means the single character new line. Let me hit run and show you what I mean. Perfect. Hello world stir 11. So now it goes to the next one. There's a bunch of these escape characters. So that's /n. Who wants to take a wild guess what /t is going to do? Looks like it. /t is tab. Because again, if I go here and start pressing tab, well, it's not really going to work quite the right way, right? It just tabs over. I want to actually get this, like the character tab. So there we go. Now you might be asking, because if I do this, we see this here. Now in some programming languages, however, it's going to see this and go, oh, I need to parse the W with it, but it's kind of unhappy. So in many languages, if you want, and see how I did 2 slashes here? In many programming languages, Python was just being nice. Where it saw the single slash and was like, okay, well that's /W is not an escape character. But imagine I did something like this. Hello new world. Hello ooh world. That's problematic, right? So if you really want to print out a slash and not do escape characters, you just do 2 slash. You like escape the slash. So there we go. So there it's happy. Again, none of this is, oh, I got to remember this right now. Otherwise, it's a, hey, FYI, these are things. You'll run into them. Remember that there are things so you can go look it up later. Is you have a question? Oh, okay. No worries, no worries. Oops. So yeah, there are a bunch. So traditionally speaking, and we talked about this before, but traditionally speaking, we are encoding information and decoding information when working with the computer, right? I write the string hello. The computer can only really keep track of the zeros and ones, and really all it keeps track of is low voltages and high voltages. So nowhere in that computer can we go find the letter H followed by the letter E followed by the letter L and so on. We have to encode it somehow. And encode is a special way to, bless you, is a special way to take information, convert how it's represented, to store it somewhere, for example, and then later, if I want that information, I gotta know how to decode it to interpret it the right way. But if all I can use to represent things are zeros and ones, I'm gonna have to use like zeros and ones to encode everything. Whether it's a pixel, a string, an integer, a float, they're all zeros and ones. So how am I going to encode and decode these things and know, like, well, how do I encode, decode this stuff? In certain programming languages, this is far more obvious. When I say certain like older ones, as time has gone on and like the level of abstraction we deal with programming has improved, for lack of a better term, we have other. So Python doesn't really like think about this in terms of the same zeros and ones. But let's go classically speaking inside a computer. I've got like a 0, 1, 0, 0, 1, 1. You know, they all take up a spot in RAM. So if we click on this, and it's hard to see, but the letter A, the single character A, has the value 97. So the number 97, the integer 97, and the character A have the exact same set of zeros and ones to represent those things. But the computer doesn't know how to decode it based on those zeros and ones. It has to have like that context. It has to know like, okay, these zeros and ones are for a character or string. These zeros and ones are for an integer. And based on that, it can decode those things. So I'm just going to take this and just give you a quick little example. So if I do this and then print out what we see 97. This is, remember how like I convert things to strings with str? Ord is like turn it into like an ordinal. I'm pretty sure that's what it means. I've never actually looked it up. I can only assume it's ord. Can someone actually verify that? Someone look up Python ord and let me know if it stands for ordinal. But I'm converting it into an ordinal, like a number. Ordinal? Aha! Who here has heard the word ordinal before? One person. So I got a big surprise for you. You all know what this means, except you probably haven't heard the word for it. It means that there's like an order to it, like the numbers, what comes after, if we're talking integers, like, well, 2, like there's an ordering. There's like this implicit ordering in these numbers. But there are values that, you know what, let's not get into it. But ordinal like number, okay? Great. We could think of it like that. So if I do this, it says that. I can take, what is the type of what? It's an int. All right, it actually turned it into an integer. Cool. Now I can print out equals the str of what, and then do this. So what I've done here is I've taken the letter A, turned it into a number, printed it out, and proven to you that, yes, it's an integer. Then I'm going to take that A that was converted into a number, the integer 97, and say, okay, be a character. So there we go. Wait, why did it print? Oh, because I never converted the type. str. Wait, what? This doesn't make any sense. It's the string of what? Pardon?
There was something else instead of string there that you did that converted into a letter. I don't remember.
Char. There we go. Much better. So, there we go. I've now converted it back to a character. Now let's have a quick look. See if I can get the binary of it. How do I do this again? Bin. Looks like this could be. No. String object can be entered as an integer. Okay. Int. Or ord. Great. So I've taken the A, and I'll just take the what as well. Well, here, let's just take A, and then 97. There. Sure. Can we not convert this one? I guess it needs to be like this. Okay, it's already an integer. All right, there we go. So I now said, tell me what, like, the zeros and ones. I guess I had to convert it to an ordinal first, which is kind of annoying because it might hide the fact, it might kind of hide the fact that it's the same zeros and ones. But I basically said, tell me the zeros and ones that mean A, and tell me the zeros and ones that mean 97. And it's the same. But it depends on what the type is. Yeah?
Why is there a B?
Par?
Why is there a B?
Oh, 0B. That means, it's just like binary. That's what that means. And let's see if I can do this. OX means hex. Bingo. Hexadecimal. When you don't see anything, you assume it's base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we loop back to 1, 0, 1, 1, and so on. In base 2, it's 0, 1, 1, 0, 1, 1, 1, 0, 0, and so on. In hex, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, where F means 15. So the single F means 15. And in computers, we like hex because it's, well, and I think we can actually do oct, maybe too. Nope. Let's try that again. Yep. So we can get an octadecimal. I don't even know what you call it. That's 0, 1, 2, 3, 4, 5, 6, 7, 1, 0, where 1, 0 means 8. These are all just different encodings for a value, which seems weird. Memorizing binary and oct and hex, not important right now. It's just a neat little interesting thing.
Right now, it will be at some point if we just do computer science.
A little bit, yeah. Not in huge detail, but a lot of times when I'll go on a tiny little tangent here. This is going to become really important when you learn about architecture. Raise your hand if you're considering a computer science degree. This is sad to me. Come on. All right, so if you're considering computer science, when you get to like your architecture course, that's where you're going to see more of this. Now the binary numbers they mean zeros and ones, but when you have a hex, I could take, oh no, I could take, my TA stole my markers. I could take a series of 16 ones and zeros, or 8 ones and zeros. So like 0, 0, 1, 0, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 9. Okay? And this can represent up to, 1, 2, 4, 8. Am I doing this right? 1, 1, 1, 1 is 15. Perfect. So I could represent these 4 bits as a single hexadecimal number. So this means 0 to 4. So I would write this as 4. And this would be 8, 9, 10. And this would be A. So A4 is a quick and easy way of just kind of like representing those zeros and ones. That's the only place it's really going to pop up a lot if you take architecture. And that's when you're thinking about like the logic gates and how these computing machines work. But anyways. All right. Formatting output. So this is like this is the old-fashioned way of doing it. Again, it's going to be very common in many programming languages. Where, like, if you have a floating point number, And you only really want to show, like, there's A, 1.235. And I want to print it out, but give it some formatting rules. I can say, okay, print format to 2 decimal places, %.2f. I'm going to tell you, probably very few programmers have memorized all of these rules about the formatting and whatnot. Every single time I need to do this, I whip open Google and say, okay, string format examples, and relearn it every time, because I don't do it often enough. So no one is expecting you to memorize the string formatting stuff. So if I do .2f %a, which is kind of funny syntax, it's going to take the value a and replace it where it sees that first % sign, the only % sign in this example, and replace it with like, oh, the float, but I only want 2 decimals on the right-hand side of the decimal. Okay? Then if we have another thing, if I have b, where it's 4.39999, and I want to print out 2 things, well, I can do that, but I have to make the thing on the right like a tuple. Fancy way of saying put it between round brackets. So now I can have %2f and then %.4f, which says give me 4 decimal places. And in this case, it actually does the rounding for us, which is kind of neat. See, it didn't truncate, it actually rounded. Cool. If you want, so let's say I have 1.3111, I can say, like, pad it with 5 characters on the left-hand side of the decimal, and then I want only 3 on the right-hand side. So, no, I want 1 on the right-hand side, actually. So you can see that the number of characters on the left-hand side, and mind the fact that there is a space here, is, that's the 1 space. 1, 2, maybe it doesn't count that. Oh, wait, I think 1, 2, 3, 4, 5. Yes, that's what it is. When the 5 is on the left, it's going to say how much space the thing can take up in total. So this is really handy if you want to have right justified things if you're printing it out. It's neat. And yeah, it's just, oh yeah, and you can actually left justify stuff with a %, which is kind of cool. And you can get really fancy if you want. The whole point of all this is there's nice ways to format strings. There's also in Python a much nicer way, and in Java as well. It's going to use this thing called dot format and f strings, which I won't show you. If you want to use it, go ahead and learn. It'll take you 2 seconds if you just Google it. But the % strategy is going to be common among many programming languages, especially the older ones. Any questions about any of that string formatting stuff? Again, the whole point of this is showing you that there are ways to do this. Don't bother memorizing it. Just be aware that there's ways to do it, and then when you want to do it, go find a little cheat sheet online, because that's literally what I do. I've noticed, so sometimes, especially in the lab, right? Sometimes a student will ask me a question, like, oh, how do I do this in Python? And I'll be like, oh, great news, go to Google. Half the time, it's because I don't know offhand, because programmers don't commit a lot of those things to memory. They go, oh yeah, I know Google exists, so I won't bother memorizing that. I'll just Google it. So half the time when I'm telling you to Google it is because that's literally what I would do to tell you the answer, because I just don't know the answer offhand sometimes. So it's FYI, I'm not being, like I was saying, I'm not being a jerk. I legit don't know, and that's programming, is, how do I do this in Python? Right. Okay. So, now to talk a little bit about objects. Now, before I carry on, Python is a fantastic programming language that abstracts a lot of ideas away from you to make your life a lot nicer, cleaner, and whatever. It's wonderful. Probably, it's the most common programming language I use by far. But Python kind of hides hides some of the underlying mechanics and pretends to act a certain way when in reality it's acting a very different way under the hood. So, like, everything in Python is an object. But what I'm going to talk about now is primitive types versus objects. Again, in Python, they're actually like the same thing. It's just that the objects in Python pretend to not be objects. Or in other programming languages, there are a very clear difference. But I'm just warning you that I'm not teaching you Python. I'm kind of teaching you, like, okay, here's the idea. So, primitive types are your things like your integers, your floats, individual characters, which don't really exist in Python, and like your booleans, okay? They are things that, like, okay, here's an integer. I want to store the number 752. Perfect. I know I can fit the number 752 in 32 bits easily into RAM. Wonderful. Same with like these characters, same with those floating point numbers. I know how much. They are nice cookie cutter values. We do run into issues when the values get larger than what we can represent with like 32 zeros and ones, but we have ways around it. The point is, with these types, they're nice and easy to work with. In fact, we kind of saw an example of how, like, well, you know, the zeros and ones can mean 97 on the character A. Well, yeah, you know, because they're primitive types, and it's just these easy things to interpret, just depending on what the types are. Alternatively, we have objects. Raise your hand if you've heard object-oriented programming before. Okay, a couple people. So, the way we've been programming so far is arguably very, like, procedural. Anyways. Where, like, okay, you know, you write your statements, they do things. But in reality, Python's very object-oriented. And there are other, like, there is, like, an attachment to this procedural style language where we have, like, throw objects in there, and we can do, like, object-oriented style programming. Which we're going to do a little bit later as we go. You all technically are doing it currently. It's just, it's very hidden from you. So objects are a way to store information in like a type, but when I don't have a nice cookie cutter rule for those types, like strings, for example. A string, if I have the string that contains the contents of chapter 5 of your favorite book, I don't know, like, I cannot know right now how big that is. I don't know how big it is. So, like, I don't know, like, my computer won't know how much, you know, RAM it needs to set aside for you. So we got a problem. You might say, like, well, why don't you just calculate it, get the length of the string? Well, this is where things get kind of complex, because if I have the string A equals hello, you know, print A, print, you know, I can look at this and go like, well, okay, hello, you know, it's 5. So before I hit run, like even before I hit run, you might say to yourself, okay, look, great, it's a string, but I know that that string is length 5, and I know that that string is made up of characters, so I should be able to go like, okay, it's 5, I need a chunk of RAM for 5 characters. Great, I can do that, right? Well, before I hit run, you can kind of do that calculation. Does that seem reasonable?
No.
Raise your hand, please. Raise your hand if you think it's reasonable. Of course it is, you know? It knows what it is. Now, let's put a pin in this example. If I go here and say an int equals 5, if I hit run, the computer, before I hit run, can be like, oh, okay, they're making an integer. Like, I don't need to run this code in order to go like, okay, well, that add integer is actually the integer 5, and it's an integer, so I know it can sit in one of these seats really easily. Right? Cool. Happy with that? Yeah? So, if I change this to something like this, nope. When I hit run, Python actually So the moment I hit run, Python now does not know. In the previous example, an int was 5. The moment I hit run, Python's like, well, it's 5. So like even before I start executing the rest of the code, I can know it's 5 and go store it. But here, Python's in a bit of a pickle because it's like, well, I don't know what the value is. But I know it's going to be an integer. So I'm going to be fine saying like, okay, I don't know what the value is, but I know I can put it in one of those seats. It's going to nicely fit in one of those seats. So it doesn't really matter to me. No, it didn't work because I didn't actually enter something. 66. Great, it's 66. So although it didn't know the value, what the value of that integer was didn't really matter because it knew it's going to fit in that one seat just nicely. Let's go back up here with this example here, A. Well, hello, it's just a string of characters of length 5. So before I hit run, or like the instant I hit run, but the program doesn't actually start running, the computer can look at the code and say, okay, well, hello, well, that's okay, great. Why don't you just go get 5 seats for the characters? Great. Cool. But if I change this to this, now we're in big trouble. Because there is no way for Python to know how much room this is going to need before I enter anything. It doesn't know beforehand. It needs to wait until runtime before it can make any conclusions about how much space it needs to set aside. So this is the pickle. This is where we run into an issue. Because if it's an integer, if it's a boolean, if it's a float, great. But imagine programming without strings. That'd kind of suck. And there's a lot of other things that we're going to start using, a lot of other objects out there that we're going to start using that we can't fit into these nice cookie-cutter chunks of RAM. We need to get fancy in how we're managing this. And we want to be able to use these things because it makes programming so much easier, a lot more abstract. So we need a good way to deal with this. And this is where like objects come in. Again, this is very high level. The discussion I'm having is kept fairly abstract, and there are some other details involved. But here's the idea. Python's waiting for me to enter something, and at this point, until I give it the input, it has no idea how much RAM to set aside. Where I want your brain right now is, I don't really want you thinking like, RAM, oh my gosh, I need to know all about RAM. That's not the point. The point is, it's got to get stored somewhere, but I don't know how much, space it needs. An integer, I can nicely put in one seat. I cannot stuff the contents of your chapter 5 of your favorite book in that one seat. I can't do it. So we're in trouble. So primitive types, other things, strings, numpy, whatever. These are objects. We are going to make our own objects even. Later in the course, you will make your own objects. Like you will basically make something of its own type. But the first object that we're playing with is string. Now, if you notice this and this. Oops, wrong way. Okay, I can stop you. Print is an example of a function. It's like f of x. Okay? So print is an example of a function. That char is in function that did the linear search, that's a function. But there's something else called a method. That's basically a function with a little asterisk attached to it. At first you might hate this, but you're going to soon like it. So if I have print, okay, let's create a string. So this is a function that will take this string and print it out. Great. Now, this string object here, though, a string is a variable that gets me to a string object. If I say a string dot. Now, if you're following along, do this. A string dot. You will see a list of methods and attributes. We'll talk about those a little later. But you will see a list of methods and attributes that you can call on your string. Capitalize, casefold, center, count, encode, ends with, ends, expand tabs, find, format, format map, index. There's a lot of things here. If I do capitalize, oh, I guess it returns. What? Let me hover over, see what it says. Return a capitalized version of the string. A new string. No, it shouldn't. Make the first character have upper. Oh, it's only the first letter. Okay, there. There we go. So it takes a string, and it'll take the current string. Notice how I didn't, like here, I said print what? I passed the string as a parameter. With this method, it's got these parentheses, like, it's like a function. But I didn't actually pass the string as a parameter. I told the string, I was like, okay, a string, capitalize yourself. And then that returned the string that starts with a capital. Let's see what else we can have. Dot. There's probably one called like upper. Lower. You've already used this one, split. Raise your hand if you use split. Everyone put your hand up. Of course you have. You use that in labs. That's a method. That's telling a specific string to split and then return the list. But notice that it doesn't, I didn't need to say split and then give it the string I want to split. I just told the string to split. So this is a method. Upper, perfect. And look, it's really cool too. I don't know if you've noticed this. If you hover over these things, return a copy of the string converted to uppercase. There. Cool. So there are built-in methods for specific objects. I can type print and give it a string to print out, or I can give it an integer to print out, or a float to print out, whatever. But when I call, like, whatever the name of the string variable is, dot upper, it's modifying the thing that I'm telling to uppercase. In fact, in this case, it's not modifying it. It's creating a copy and returning the copy. Because, of course, strings are what? Did anyone mumble immutable? One person? Well done. But anyways, it makes a copy. There are a bunch. You couldn't, any object out there that you make, you can go through this and be like, oh, find, split, rsplit, partition, lower, join, is upper, is numeric, false. Is numeric, let's see what it does. Returns true if the string is a numeric string, false otherwise. A string is numeric if all characters of the string are numeric and there is at least one character in the string. Meaning, true. So there are these methods and there's functions. They're very, 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 very similar. Some methods do take parameters as well, like the split one. If I go here and say split, here's an example of it with no parameter. But I can give it the parameter L. And now it's split based on what I gave it as a parameter. So now I split on the L's. I can split on the W. Nope. There we go. So hello with a space, because I guess, I didn't get rid of the space. I kept it. But by default, if you don't specify something, it's the string. It's the same as me doing this, or it's the space. That's the same. So some methods can take parameters, some don't. But the method is kind of working on a specific instance of an object. I'm working on a specific string. Imagine each of you are a string object, okay? And like, what's your first name? Riley. What's your first name? Yeah. Noel? Nolan. If I'd said Riley to upper, you're all strings. Which string does that matter to, though? Everyone point at Riley. Now, if I say Nolan, is that right? Nolan is numeric. Who am I asking? All of you are strings, but who am I asking? Everyone point to Nolan. It's only affecting the individual one that I'm asking about. In the same way where I say print Riley or Nolan. Riley? Yeah. It's only going to print out the individual one. I saw your hand up.
I was just asking, how do you get the hover over thing? When I hover my mouse over the upper, I don't get that.
Yeah, sometimes it will work for me, sometimes
Oh.
it won't. I end up having to delete it and then retype it in, and sometimes it'll show up for me.
Maybe hit run first, too. Oh, yeah, it's not doing it now.
Yeah.
Oh, now it did. Whatever.
Alright.
I don't know. Good question, though. It's Colab, yeah. If other IDEs will have something similar, here it is with Colab. Here it is in PyCharm. But anyways, there you go. Why are they like this? Because you're only ever going to get a feel for, well, what's a method? How do I know if it's a method or a function? You go look. You'll get a feel for it pretty quickly. At this stage, it might be like, how am I going to know? That's not something you really need to be worried about. It'll become very clear as you go. And what else? Yeah, whatever, practice. And if you ever want to do extra crazy stuff with strings, there's a string module as well that has things kind of like the math module, but this one's for strings. Yeah?
The midterms on the 20th, right?
Someone double check that. I'm pretty sure it's the 20th, because I don't think we have class on the 21st. All right. See y'all later.